I start recording.
Oh, yeah. Hey, everybody. Welcome to the 2019 March 27th API Machinery Food Meeting. As is our custom nowadays, I've put some caps onto the list to start off our meeting with. Jordan, I think on there. Do you want to tell us about Go module support? Did not on the call yet. Okay, Chow, you're on the call. Do you want to tell us about storage migrator beta requirements? We can come back to the other one.
Can I ask people to mute if you're not talking because keyboards aren't noisy?
Yes. So for the storage migrator, the goal is to reach beta in Q2, and this PR is mostly just updating our cap with the beta requirements. Mostly it's of just adding more tests to make sure the migrator system works under stress. Also add the visibility requirements, adding more metrics. So please check it out if you are interested. And we do want to have some early adopters after it reaches beta, and it will be a crucial step before you can safely upgrade your cluster.
Yeah, I think both David and I have skimmed this, and it is likely to be merged quite shortly. So, if interests you, please look at it very quickly.
Yeah.
Okay. Let's see. Let's talk about. I added this last one, the serialization cache. Wojciech just published this cap like yesterday or something. So if you haven't seen it until just now, let's try. I've looked at it briefly. David looked at it briefly. It's proposing that we begin serializing objects, or sorry, caching the serialization of objects part of the as part of the, like in some sort of smart object format that gets passed around and stored. I'm still not totally sure that I don't know. I'm still thinking. I'm still not sure what I think about it. But if you have thoughts, I put this on here as like FYI, not because I expect us to take action today, but I just wanted
Yeah, I would say that people who are familiar with the watch cache, your feedback would be really useful. If you're familiar with the deserialization cache, feedback would be useful. If you remember the smart objects that have been discussed off and on here and in SIG CLI that are aware of their own serialization, this is the KEP to come in and comment on.
Yeah. Yeah. So it's very early for this KEP. So yeah, lots of opportunity to help us out here. Okay, and Jordan, looks like you're here now.
Jordan's back, yeah.
Yeah. Would you like to tell us about Go module support?
Yeah, sorry about that. Do you want me to pull this up? I can give a demo of it. I can talk a little bit about what we're thinking about doing. Oh, you have it up. So Go modules are available starting in Go 1.11. They're really solidified in Go 1.12, which we just switched to for Kubernetes 1.14. And the plan of record is for them to be enabled by default starting in Go 1.13, which means that we need to get Kubernetes in shape to interoperate with Go modules in the 1.15 timeframe, because before 1.16 is out, Go 1.13 will be out and being used. Not only do we need to do this just to interoperate well with Go, it actually works way better than what we're currently using for dependency management, which is GoDep. And so there's a pull request that actually switches our vendoring tools to use Go modules, and comparing how fast CI runs. It takes 30 minutes to verify vendor with GoDeps, and it takes 3 minutes with Go modules. It also means that you can run update vendor locally on your own machine and get reproducible results. You can do it on any operating system, which is awesome. There are some other interesting parts of Go modules that we could maybe take advantage of in the future, like semantic import versioning. But that requires all of our dependencies to also support semantic import versioning, which almost none of them do yet. So that's more of a future-looking possible benefit. So this KEP is describing what we plan to do. The first aspect is switching our vendoring tools to use Go modules. That's pretty self-contained. That's limited to just the update vendor and verify vendor and update vendor licenses scripts.
Question about that.
Yeah.
Today we publish at least a godep.json from staging, each of the staging repos. I think we also publish a different format for dep.
We don't publish a dep format that I'm aware of. Stefan didn't mention that.
Okay, but we definitely publish godep.json. Are we going to continue publishing that, or I mean, certainly not forever, but there needs to be a cutover for people.
So right now we have two different formats of Godep's JSON files. We have the ones that are checked into Kubernetes, which have dummy revisions for all of the staging components, like revision XXXXXXXXX.
Right.
So obviously those can't be used directly by Godeps or Glide or anything. At publish time, when we take those subfolders inside the Kubernetes repo and push them out to their own repositories, at that point, we, in the publishing bot, rewrite those to insert the actual SHAs that the staging components can use to find each other. And so the plan is to continue publishing that at publish time, but just to generate it from the dependencies in the Go modules. So when we publish out to the individual repos, we would generate Godep's JSON files for use by things like Glide or Godeps.
Okay, and it will still be godep.json?
Yeah, it'll still be named the same. Right now, my best guess at a time frame for that would be until Go modules are on by default. So I would anticipate publishing those at least until Go 1.13. If the cost is low to continue doing it, then we could consider doing it indefinitely, I guess.
I don't know indefinitely, but having an overlap is going to be really
helpful. At least until Go 1.13 is the proposal in the current PR.
Okay.
This describes some of the options we have around versioning. The proposal is actually to stick with what we're currently doing. It is no worse with Go modules, and it leaves our options open. Some of the implications of switching to major versions or semantic import versioning are irreversible. And so for the first phase, the goal is really just to get our vendoring tools working well and make sure the things we publish out can be consumed by module-aware consumers well. So that's an overview of, there's the building synthetic Godeps files.
So is the staging folder still symlink in the vendor? It didn't change anything there?
Yeah, so right now in the Go 1.12 timeframe, modules are able to be used, but they are not on by default. And so the goal is to structure the Kubernetes repositories so that it works for people who are using modules and it works for people who are not using modules, which means vendor and staging symlinks exist, at least for a couple more releases. There are other considerations around vendoring aside from the staging symlink thing, like being able to check out Kubernetes and have a reproducible build. So before we got rid of that, we would need to resolve some of those questions as well.
Okay. But when Go goes to is it 1.3?
13.
Is the plan to like stop doing the weird symlink and vendor directory and like actually use Go module rewriting to link everything up correctly?
We would like to convert all of our build scripts to use Go modules. And at the point where you have them using Go modules, you have options. You can either build pointing at a local vendor dir, even with modules, or you can build pointing at a local module cache. Again, the questions around like hermetic builds, you have to get a little bit more opinionated if you want to have a hermetic build and not have it using a local vendor dir that's checked in. So we need to figure out who is depending on building Kubernetes and how, and make sure we don't break them.
Yeah, I think a lot of people who have distros would like to be able to have a consistent hermetic build.
So I have two thoughts. One is, Jordan, is this informational or is this action required and there's something we need to do?
This is informational. I actually wanted to show what it would look like using it if we have a few minutes.
Yeah, I think we do have time. I'd love to see that. The second thing I was going to suggest is related, which is I wonder if if the thing you're about to show us doesn't cover this, but I wonder if it would be possible for you to give us like a 10 or 15 minute primer on Go modules at the next SIG API Machinery. I think it would be useful to have it recorded how Go is about to work, since this is going to affect everybody who uses Go.
Yeah. I was planning to do that. I was planning to finish doing the Go module work, since every day I learn something new. And I'm hesitant to say this is how they work prior to actually being sure that that's how they work. But
well, you're welcome to like do a part 2 with like
Amended.
yeah, with like the
errata.
situation. Yeah. This is how I
All
thought.
education is a series of progressively smaller lies. Is that what you're saying?
Yeah, exactly. Yeah, so please, if you have a demo, see it.
Yeah, if
Can you share the screen, or I have to?
Yeah, I think you have to stop first.
Let me stop.
all right, can you see that?
Yes.
We can. Yes. Perfect.
So when you start using Go modules, there are two files that show up. The first is the Go mod file, which defines a few things. It indicates the name of your module. It records the version of Go that was last used to modify it. Then it lists a bunch of dependencies, and these are in the form of their root import path and the version that you depend on. Now, anytime you see require, you actually have to switch that in your mind to like require greater than or equal to, because Go modules use minimal version selection, which means that all of the modules involved in a build get to require versions, and it takes the greatest of the required versions for a particular module, and that's what gets used.
Yeah.
So when we say we want to use version OEEFF of this module, if one of our dependencies requires a newer version, then that will actually get used. This is what's called a pseudo version. This dependency, and you'll notice almost all of our dependencies actually don't use semantic version tags, or we are not on commits that are tagged with semantic versions. And so Go generates a pseudo version, which consists of the timestamp of that commit and then the SHA of that commit.
So
Jordan,
can I pause you there? Walter is trying to raise his hand, but I don't think he's on camera.
Right. Jordan, when you say greater than or equal, is that
completely greater than or equal, or will you get a conflict if the major minor on semver conflict?
Completely.
So it doesn't respect semver at all.
Correct.
So that means that if one of ours happen to depend on, say, that system stat v1, we would actually use system stat v1.
In the absence of what I'm going to talk about later, yes.
Oh, okay. I thought it actually depended on both both in that case, but
that is something. Series of progressively smaller lies. We're starting small.
okay. I'm curious about the how do you deduce greater than or equal to on the suffix there? Is it just logically?
That's the point of the date stamp
Okay.
in the pseudo version. It makes it so that things that are otherwise incomparable become comparable. So we have a bunch of require statements. When you actually start up a module for the first time, if you say go mod init, if you have a go.deps.json file, it will actually populate all these require directives with the existing revisions that your go.deps.json said you depended on, which is kind of nice. So we list a bunch of requirements. Then there's another section called replace. And
I see something in the version set plus incompatible. What was that?
That means that this dependency has get tags that are using semver, but they are not using get module versioning. So the way get modules want you to do major versions is by actually changing the import path of your module. And so what that would mean would be if we wanted to bump customize to v2 and do it the go module way with semantic import versioning, we would actually have SIGs kates.io/customize/v2. And then we would depend on v2.0.3 of that. And that is what lets you actually have two different major versions of a module coexist in the same build. So from Go's perspective, it's a completely different package. You could accomplish the same thing by having one version, one branch, and just having a v2 package in it. That would accomplish the same thing. And so this plus incompatible indicates that this is a semantic version tag, but this is not using semantic version imports. And so it throws the plus incompatible on there to let you know, hey, if one of your dependencies depends on v3 of this customize component, we're not going to be able to let you use both of those simultaneously. And all of this normalization and generation of pseudo versions and stuff is done by Go tooling. If you run like go mod tidy and it formats your module file, it will actually go resolve these and figure out the timestamps of the SHAs and sort it and put it in this format. So this is all done by Go tooling. All right, so that's the require section. That lets all the modules involved in a build say, here's the version I would like. Here's the minimum version I would like. Now, the top level module in a build is special. It gets to exert control. And so even though there are lots of modules, lots of dependencies and transitive dependencies involved in a build, the top level module gets to be the decider. And it can do a couple different things. First of all, it can pin versions. And so you express this by saying, whenever I want to replace, whenever we're deciding what to use for this module, I am going to replace it with this module at this version. And so this is what lets Kubernetes pin versions no matter what transitive dependencies are trying to do. Now there are a couple things you could do here. One, you can pin to a particular version, so that's neat. Another thing you can do is do rewriting. So you could say whenever the system stat module is requested, I actually want you to pull that content from some other module entirely. So this could be useful in cases where Kubernetes has a dependency that is unmaintained and there's a security vulnerability found in it. We could use replace to say the system stat, to pick on them, and I'm sure they're well maintained. This is no aspersions cast. We're actually going to point to our own fork of this at some version where we fixed a security bug and the upstream wasn't maintained and we couldn't get the fix upstreamed.
Is this equivalent to the glide ability to point at a different repo?
Yes.
Do you think we would have used this if it had been available instead of making, say, klog for glog?
Yes.
Possibly.
If you were API equivalent, yes.
Yeah.
We use it in OpenShift for having different forks that we can maintain separately.
Yeah. So that's handy. It's also super handy for like working locally. If you've got a set of repos and you want to point somewhere else temporarily and do builds and let things actually resolve and actually build, that's really nice. And then the last thing you can do, and if I jump down, you can actually point to locations on disk instead of remote locations. And so this lets us indicate that whenever one of our staging modules is being looked for, we can locate it relative to the Kubernetes root module. So this means that our staging folder doesn't have to follow the go path structure anymore. We could locate it anywhere.
Question on that: is the rule recursive? Like, does it match a prefix?
No. Is the rule recursive?
Yeah, like Kate's /io /API server. If I say API server / like, I don't know what something is in there, options or something.
No, these are modules. Okay. So the thing on the left has to be the name of a module. It can't be the name of a particular package inside that module.
Okay, so
that means it works for the.
Okay, so it is so everything that I mentioned inside that also gets this.
Oh yes, sorry. Yeah, so all packages provided by that module. This is telling where to locate the module, and so then it goes to there and looks up the .mod file that's located there. And
is the
all packages that module provides, yes, get
is
located.
the module defined by the first two path elements, or the first three if you have a version, or how does it determine how much of the import path is the module and how much is the package?
Modules are just names. I'm not actually sure. I think some of the original Go Get semantics about like understanding different kinds of version control providers and things like that. Like it knows how to find modules from GitHub and Google Code and Go Package, and like some of those come into play. But this lets you specify arbitrary modules. So I could have a module that had 3 segments or 4 segments or something, and point it at a location.
There's an example at the top of your string with golang.org/x/.
Yep.
Gotta ask, did they add this because we are crazy, or were they planning to do this anyway?
I don't know.
I did have a conversation with somebody working on this effort before it was public. So I think they had already anticipated this use case, but I'm sure. I do think we're looking at Kubernetes as one of the problems that needed to be handled.
So this actually is something that's nicer than glide, like the ability to point to a local directory. This is really, really handy. And so that's what the structure of the Kubernetes go.mod file looks like. Only the top level module gets to specify replace directives. Other dependency modules can specify them, but they don't get honored in a build. Only the top level
Can a repo be in both require and replace?
Say that again?
Can a repo be in both require and replace?
Yes, and we do that. So actually, so we are replacing all of our staging repos to point them at the relative paths, but then up in the require section, we are also requiring them. And because they're local and not fetched from a VCS, they don't have a SHA associated.
I have a question, which is, if your replacement uses a version which doesn't meet the requirements, is that a compile error?
Doesn't meet the requirements.
Yeah, like if well, I guess V000 is going to be easy to satisfy, but if I replace one of the others with a version that is lower, like the disk version is lower, does that fail to compile, or does it assume that your replacement is okay?
Replacement wins. These are unconditional replacements. You can replace specific versions as well. So on the left side, you could say, I want to replace cloud.google.com/go v1 with a particular thing. You could conditionalize the replacements if you wanted to, but these are unconditional. Now, obviously, if you point at a version and it pulls down the content for that version and it actually won't compile, well, yeah, at that point you've made a compile error. But replace wins unconditionally as far as determining what content to pull down for the build.
Do you pull replace sections from your dependencies?
No, only the top level module gets to dictate replace.
So the replace section, they are all handwritten.
I'm sorry, say that again?
Did you manually edit the replace section?
Did you manually write the replace section?
Well, I wrote a script to do it.
Yeah, that's the same. So GoTool doesn't help you, right?
No. So there are tools to do it. So let me have to opt into using Go modules because it's not on by default. So the Go mod edit command will do things like dump the current Go module file in JSON format, and then you can use whatever tool you want to pull information out of that or decide what you want to do, and then you can write commands to manipulate the Go mod file. So if you look at the update vendor script in the branch that I have open for the Go module work, there's a lot of this where I sweep through the existing stuff, and one of the things I do is look at all the require statements and then generate replace statements to make sure that we're pinning things at the top level so that we have equivalent control to the current GoDeps JSON file.
It does seem like you could have a condition where the require statement is effectively never tested at the top level because there's a replace statement.
Yeah, and the Go tooling does a few things that are kind of wacky. It aggressively updates the requires statements in your Go mod file to reflect reality. So if we say we want v10 of something and one of our dependencies says it wants v11, Go tooling will actually update your top level Go mod file to say, no, actually you want 11 because you're getting 11 anyway because this dependency says it wants 11. So it will bubble up like the actual versions that would have been selected into your require statements at the top. Now your replace statements still rule, but that at least gives you visibility to like, hey, require is 11 and we're pinning to 10, like we have a mismatch here. So, I mean, half the time that was nice because I could see what the effective minimum version was, barring our pinned replaces. Half the time it was driving me insane because like Go list, which I would have thought would be read only, was like changing my Go mod file.
Yeah, that's weird. Okay, We're half an hour in, and our agenda has grown more items, so maybe we can time box this. Any parting thoughts on this, Jordan?
Not really. That's kind of an overview. The bits that we're using, some of the forward-looking things that we might be able to use in the future if all of our dependencies behave better. And yeah, the short version is you can run update vendor locally in 1.5 minutes, and it works every time, which is awesome.
That's awesome. Thank you very much.
A quick question. So what is the reason for the speed up?
I think it's a combination of GoDeps being terrible and Go modules making some simplifying assumptions about how they determine versioning. The way Go modules determine versioning is scan dependencies and take the biggest version requested instead of trying to do like tons and tons and tons of graph resolution and like letting things bound min and max. It just doesn't let you do that. You either pin at the top level or it just takes the max of all the requested ones. So yeah, it's fast.
Oh, that was glowing.
You know what? After having worked on this for a couple of weeks, I will take fast. Yeah.
Glad it's fast.
Okay. Thanks again, Jordan. Let's see. Clayton added some items to the agenda, and one of them was a KEP, which didn't get included in the KEP roundup because it's already merged.
I only have a question. Well, it was more of a follow-up. I think it's also fast because Go modules is more able to aggressively cache different versions of dependencies, I believe.
Yes, Go modules does local caching. Yeah.
Even without the cache, it takes 3 minutes total. So it's still like 10 times faster with a clean cache.
Yeah. Okay. Which is table and partial object metadata to GA. There was really very little that could have been objectionable in this, and I already LGTM'd it, and I didn't realize that it already had approval from Clayton, so that kind of instantly merged it.
Yeah, did you make Clayton say that he was going to test to make sure partial object metadata worked? And
No, so it was, the draft was put up in implementable, but there were some notes in there about what needs to be done for GA. I am looking right now at both sides. So table is pretty good. I'm not as worried about table. We don't have a protobuf serialization for it, but I don't think that's blocking. And the reason why is Proto doesn't have the equivalent of what we're using for JSON, which is we allow you to put JSON fields into cells. And so we would have to decide on a Proto serialization. That's hard, and it correctly reports an error. We should just say we don't support Proto for table today, and I think it's a feature that could be added later when we decide on what a Proto serialization should look like. Partial object metadata. The reason to do partial object meta is to make generic controllers faster, things that only deal with. Go ahead, David.
I'm not arguing against that, but I think we, or at least several of us, remember that GC tried it, and GC isn't using it.
I was just about to get to that. So I went and looked at what we would need to do. So there's 3 controllers today that could benefit from it. The 2 that are easier are quota counting and namespace deletion. I actually went and started looking at this because namespace deletion calls JSON list on things. And so EDE tests like 30% of the time on the masters on EDE runs of the CPU time is actually doing namespace JSON lists. So there's some nice wins to have in our EDE infrastructure, and that's what got me down this. The Git paths are mostly fine. The protobuf serialization actually needs to be updated because we accidentally left out list meta. And so we're going to have to decide whether we're okay with partial object metadata list going to GA with a different protobuf ID numbering than almost every other list we have. We've made this boo-boo on a couple of beta fields where we did items and it got ID 1, and then we realized we
can't we fix it in V1? V1's a different object.
We could fix it in V1. That is a good point. So I will go take I'll dig through that. And then the gap on garbage collection controller. So unlike all the others, garbage collection controller needs to call put. And so we would have to do a server-side support for putting partial object metadata. It's not really that hard. I did a quick pass on it. It basically would require us reading the input object, merging it with the storage version, which we already have to do.
Can we not express
No.
in the form of a patch?
Yeah.
Now, garbage collector still calls update for a couple of things.
Well, but I mean, maybe it's easier to fix that than it is.
Some of those are transactional, and patch is not transactional.
Yeah, but
Can be.
a finalize might work okay, and a patch that patched the resource version as well would effectively conflict, right?
Yeah, you can actually include the resource version on a patch and get strong consistency guarantees.
Okay, and so patch will work today. So the question would be, is there value in a pure put? And so that potentially wouldn't block GA. I'll take a look at that for the garbage collection controller to move it to a patch with locking on resource version.
I thought we were already doing that, actually. Maybe.
No, it's still in 115. It's still calling up. And so I was going to also create a partial object metadata client that looks a little bit like dynamic, but it's a lot cleaner because it can use the existing serialization infra. A second note is I have an outstanding change that Jordan and I have been talking about to clean up the serialization stack in client Go. So it takes conversion out. It takes some of the hacks that David had to put in to get dynamic. And they're not hacks, sorry. Clever workarounds that David put in to get the dynamic client out the door, and cleans it up just because we don't need conversion in client Go. So I want to bring that in, comment, get some discussion going on removing conversion from client Go, which would allow us to simplify both dynamic client and partial object client, so that you would basically have a fairly straightforward, very clean code path. It takes a lot of complexity out of the special cases. I was going to link that into, I'll open another PR that has feedback to this KEP and link some of those things in.
Great.
I have a question with regards to the server-side printing and support for watches. From the CLI perspective, Get is fine. Unfortunately, the watches does not support.
It's fixed in 115. It's fixed in 115. So that went in, that was one of the first commits that went into 115. Jordan and I were trying to get it for 114. It just didn't make it over the wire.
Oh, that's awesome. Cool, thanks.
Awesome.
And I expect there may be one or two issues that come out of the changes in kube control. We could block GA on kube control being able to switch to it, but it's up to Mache and CLI.
That's great. Okay. I thought I'd give a 30-second update on the rate limiting discussion. Those of us working on it had another sync up meeting, was it yesterday? And we have another one next Tuesday. Basically, we're close to converging. We're still talking about the mechanism for taking things out of the queues. Yeah, but we're pretty close on that. So look for a sort of combined PR with our collective design. I don't know. Yeah, maybe we can have that out by the next API Machinery SIG, if all goes well. If we need another round of discussion, then it'll be delayed. But we're actually converging fairly quickly, so that's great. And Mayank, I don't know if I'm saying that name correctly. Are you on the call?
Yes, I am. Yeah.
So I saw that you asked this question in Slack and nobody answered. So shame on us. Seems legit to ask in the SIG meeting. I have just one thought on it, which is it seems like there's sort of the cause and effect are separate. Like yeah, if we broke JSON merge patch, that is pretty interesting. I think, and I hope this is documented, but I think webhooks really need to be they need to be upgraded before the rest of the control plane when you're doing an upgrade, and that needs to be tested, unfortunately. But I'd love it if you could describe the JSON merge patch thing that you have observed.
Correct. Yeah. So I'm not an expert. So I mean, it's very likely that I might be doing something stupid there. So I mean, the exact patch that we were doing was basically patching a label, and that label was getting patched by the webhook after it injected a container.
Mm-hmm.
So it would inject a container and then patch a label saying injected, and that would say, yes, I'm done with my work. And as of 1.9, it was working. And when we upgraded to 1.10, it basically replaced all the labels with that just one label.
Mm-hmm.
And here is the diff that is now working. So if you see, the older behavior was that the child was, we were basically, the value was this Sherpa injector dot service mesh / status as injected. The new.
Sorry, are you sharing your screen? I'm not.
I basically pasted it on chat.
In the chat. I see.
And then the fix that is working is basically the path now includes the whole status field in the labels. Does that make sense, or?
I am surprised that the first one worked.
The first one was a bug, actually. Yeah. That is not the JSON merge spec.
Okay. So that's basically like we were using it incorrectly.
Yeah, there were two bugs that I'm aware of. One was in the JSON merge library, but I don't think that was this. The other was that we weren't actually we weren't decoding into a new object. And so whatever the current state of the object was, the result of your patch would actually get overlaid on top of it. And that meant that you couldn't actually remove fields using a mutating webhook. And 1.9 sounds like about the right time frame for that.
But would that cause the label to be correctly patched?
So with the previous behavior, your patch would have come in, replaced all the labels with your single label, and then that result would have gotten merged back onto the original existing object, which would have restored all the other original labels.
Interesting.
And that was actually a bug that meant that you couldn't delete things with a mutating webhook.
Okay.
Let me see if I can track down the bug fix and link to it just to close the loop and make sure that was.
Yes, that would be awesome.
Yeah.
The second thing I think I heard was that webhooks should be upgraded before the control plane. Did I get that right?
Yeah. Unfortunately, we didn't build in there's not necessarily a mechanism for telling if a webhook is incompatible with the new control plane. So it is kind of left as an exercise to the reader at the moment. I think if I were running a cluster with some custom webhooks, I think it would definitely be good to have a test environment, do the upgrade in a test environment, and see how the behavior is.
Okay, so I thought now I understand correctly. I think what I heard was that webhook should be upgraded, but I think what you're saying is that you have a test environment in which do the Kubernetes upgrade and then test the webhook and make sure that.
Yeah,
well, logically,
if there is compatibility, then the proper order is to first push corrected webhooks and then do the rest of the control plane upgrade. If there's no incompatibility, then it doesn't matter.
Got it.
Well, yeah, but the thing is as versions are added, for instance, you need to make sure that you correctly deserialize what's being sent, right? So that's why logically the webhook has to go first.
Okay. The other question I have is, does the two like usability questions? One is, is this a common practice to inject or patch labels, like versus maybe it should have been annotations? I mean, of course, that would have been safer because it would have not messed up with the selectors.
Adding labels is not unreasonable.
Okay. And
I think the thing you've pasted looks like a totally reasonable label.
Okay.
I think you can't be sure that deleting the annotations wouldn't have caused the same problem. We've definitely had controllers that are a little overambitious about doing diffs and then recreating things. So I don't know that using an annotation would have been safer.
Sounds good. And then the last question I have is, like, do we recommend using strategic merge patch, whose behavior we tightly control, compared to JSON merge patch, whose libraries can be implemented in different ways?
So the answer to that is with a webhook, you don't really have a choice. It's always JSON merge patch.
Oh, I didn't know that. Okay.
Yeah, you don't have a choice. And in general, if if you're not using a webhook, like if you're just using the API, then I would recommend planning on using server-side apply as soon as that is in general usage, which hopefully will be 1.15. I hope it goes to beta.
Okay, I think I have another last question, which is basically, why do webhooks not support strategic merge patch?
So the part of the reason strategic merge patch exists is so that in the case of our lists, you need to be able to refer to an element by key in order to be useful, or by the name field or something like that, in order to be able to make a patch that remains useful in a concurrent environment where somebody else could insert a list item. You want to be able to refer to the list item based on one of its fields, not based on its index, because that could change. So to do that, we made strategic merge patch. Now, a webhook doesn't operate under that condition. It's totally fine to refer to it by index in a webhook, because there's no chance that somebody else is going to modify it before the result of the webhook is applied. So strategic merge patch is not necessary for webhooks.
Cool, thanks. I'll look forward to the bug fix if we can track that. Thanks a lot, guys.
Yep. And Clayton, I moved half of your items. Did you feel like you got through them all, or would you like to talk about things again?
Yeah, so real quick, on the client Go bit, it's about cleaning up client Go and simplifying the interfaces to get rid of some of the very proto Cube 1.0 legacy crap that's just accumulated over the years, and trying to slim it down so that it matches where we versioned APIs, versioned clients, internal client sets are gone, conversion really has no place in client Go, et cetera. It should simplify a bunch of use cases. So that's just something I want folks to, if there's a reason that conversion in client Go needs to stay around, I want to get some feedback on that. The second one, the watch stuff, regressed performance, and so Wojtek caught it, and that actually got me looking at our request serving paths. And in the last maybe 10 releases since I really went in here with Fire, we've accumulated a little bit of, brush. And so I'm doing a controlled burn through the API server stack, including one of them, and I'm been trying this out, is getting rid of Go RESTful in the serving path. We don't actually use Go RESTful for any of the decision making. We don't use it for media types. We don't use it for negotiation. We basically just pass right through into the HTTP stack. And Go RESTful is actually fairly wasteful of allocations. I put a couple fixes upstream and then just realized it wasn't worth it. So at the current point, I'm looking at just swapping out the MUX logic that we use with something that's better, faster, and doesn't allocate as much, which will give us a nice performance win on everything. I'm going to play around a little bit more and then put something up for folks to look at maybe in the next couple of days. Go RESTful really isn't involved in our serving path today, so it's a mostly available change, but there's some good wins in there, so we should get some performance just from general cleanup across the board.
If I recall correctly, we used it more prior to 1.14 when we had the old Swagger docs that we were generating.
Yeah, that's what kept me from ripping it out years ago.
Okay, yeah. So as of 1.14, we're no longer using it for that.
And fortunately, it's still very easy to initialize it and verify all the stuff's there and keep all the docs if we actually need it. And if it'll basically be we'll put a shim underneath it. It's not actually used in the serving path. And then if we find we don't need it, we can pull the whole thing out.
I know Howe is thinking about or working on fixing that huge API installer function. So
yeah, that part is in API installer we register a Go RESTful web service, which is I'm not sure if it's related, but I don't think it's used by the serving paths, and the Go RESTful web service is mainly used by
Kube API to generate a Open API spec because we need the information of passes and the verbs that we handles. So yeah, I mentioned this just to make sure when you put that out for review, make sure you tag Clayton so that the two of you don't clock each other's changes.
Yeah, my changes are actually, I touched like 10 lines in installer.go. That's how little Go RESTful impacts our actual code path. So, but yes, definitely will probably conflict if we're in there at the same time.
Yeah, awesome. That sounds great. Okay, I think
a question here on this point. This reminds me of something I've been thinking about for a while. We don't actually have any regular, as part of CI/CD, or any regular monitoring of performance of the API machinery, right?
We do. It's just in SIG scalability, and it's the meta. So most of the regressions in API server performance are caught by the 100-node scalability test. Almost every measurable one I've ever seen, we've caught there or it showed up. But I do think what I did notice, and I think to your point, Mike, is that we were growing slowly, and it was like 10 or 15 small stupid things. So those are kind of hard to catch in a performance test. I don't know what we could do there.
I don't know. Actually, I kind of sympathize with Mike's point there. Like, should we really be requiring a huge end-to-end test to catch our regression?
Clayton, your get and watch benchmark, like, I wouldn't mind running that in CI and saying the number of allocations in a get path shouldn't grow without consideration. Like,
yeah, that would be what I would suggest, is like we get a couple of these fixes and we pick a number and we say, if you go over it, you'll just fail that unit test and we'll see it. That requires some Bazel changes, and I hate Bazel, so I may need some help to deal with that aspect of it. But
okay. Yeah, I think I saw somewhere maybe we can start running our benchmarks continuously, because I don't think we do.
We don't.
Yeah.
They're excluded. That was the Bazel part I would need some assistance with.
I think that would be super useful to just run our benchmarks continuously.
The good news is that these are so easy to fix now because the profiling infrastructure is so much better, that just having maybe like the project here is we should have a good set of benchmarks and make sure we run them. There's other benchmarks that would be useful that we should be running.
Yeah, absolutely. Okay.
Are the existing benchmarks where are they described?
There are various benchmark functions scattered around the test files.
Okay, so you're talking about regular Go benchmarks.
Yes, and honestly, those have caught almost every actual performance problem we have, or those make it easy to profile and find where the cause is for most of the things. I do think we're missing something at a meta level. We have a large number of independent components that make up a request profile, audit, and so in full runs, like, part of why I've been doing this is because we've been fighting all the open API performance issues that are still there. You know, the work that Stefan and I know that folks were helping with. In the meta runs and like an overall run, I get a very different results than I will on some of the benchmarks, because things like audit and authorization and service are in there. So, but that's where I think the EDE scalability runs, because they capture profiles and you can download that profile and look at it in a flame graph in 10 seconds. And it'll tell you exactly where some of those like big heavy hitters are in the core paths.
Okay, yeah. I'm not familiar with that, so I would be interested. Maybe I guess I'll see if I can find it and figure out how to do that. I think, you know, I'm interested in promoting the Kube API machinery for more general use. And as part of that, I think we should have some, you know, documented and maintained performance results that people can refer to, you know, without getting mixed up with all the rest of Kubernetes.
Yeah, I think it would be great.
That could be interesting, but I don't know that I see that as an objective for the Kubernetes project. If you have something that you can do that with, though, it would be great if you published it.
I mean,
well,
We do expect the occasional aggregated API server, like the metrics API server.
Yeah. What I'm saying is that right now, I think that being able to catch it inside of a cube test that we catch in the scalability test works very well for our needs.
Yeah, I kind of, well, so I think it would be neat and useful if we could make some more abstract claims about the scalability of API server. Like right now, the scalability promises that the project makes are like so many nodes, so many pods, stuff like that. I think it would be great if we could make a scalability claim about like the number of objects tracked by the control plane, and like because this becomes more important as people shuffle more work into CRDs. It becomes important to know like how many CRDs can I put in the control plane. So I think some abstract claims about how the thing is supposed to scale could be pretty useful.
Right. I would also say that with thinking about how systems work at a higher level, I mean, even in Kubernetes, right? What we've got is, in some sense, this ecosystem of controllers interacting through objects, and sort of the fundamental step is from a client submitting an update to an object to a controller processing that update. So having some statement about the latency throughput of that kind of step is something that higher level designers would need and want to work with.
Yeah, okay. We are just about out of time, so I think that's an okay place to leave the conversation. Yeah, okay. We will see you all in 2 weeks. Thank you for the discussion. Yeah.
Clayton, this thing's about to evaporate. Can you post those links somewhere more permanent?
I can copy them and put them on the notes.
Yeah, that would be
Thank you.
great. Okay, thank you, everybody.